Hey Pre-Calc, today we're going to be talking about section 2.1, solve radical equations. So you did this last year in Algebra 2, and we're just reviewing it to make sure you know it, and it will be on your test. So we're just going to do an example. We're going to start right off the bat with the challenging example from last year, when you have two radicals, one on each side. So for this example, please write the square root of x minus 2. Sometimes I like to just do a little close so you know that that's all that's in the radical, equals 5 minus the square root of 15 minus x. Okay, so we want to solve for x, but the x's are locked right now into the radicals. So the first thing that you want to do is isolate the radical. So step 1, isolate radical. Now, the way this one was written, it's actually, one of them are already isolated, so we're perfect. So now what we want to do is square both sides. To eliminate the radical, because taking the square root is the opposite or inverse of squaring something. So we're going to square both sides to eliminate the radical. Okay, so that eliminates the radical on the left side, because this is the only thing that's being squared. So we're left with x minus 2 equals, and then be careful, you cannot distribute the exponent. That is one of the most common mistakes students make regularly. This exponent is saying you have to multiply this binomial twice, which means we're going to have to FOIL. So I recommend writing it out. I seriously cannot emphasize this enough. A lot of students make this mistake, no matter how many times I emphasize it. Okay, and then we're going to FOIL these. So if you don't remember foiling or double distributing, right, you do 5 times 5. Actually, I'll just bring everything down and do it. So 5 times 5 is 25. And then we have 5 times negative root 15 minus x. So that's minus 5 times the square root of 15 minus x. Then we have negative square root of 15 minus x times 5, so we have another one. And then now, because we're multiplying two of them together and it's a negative times negative, so it becomes positive, now the radical cancels out and we're left with, and I would put it in parentheses, 15 minus x, just in case this is a negative. So it doesn't actually matter for this problem, but it could for future. So we're getting closer. The next step, if we look, is going to be to combine like terms. So we can combine these two. We have a 25 and a 15. So x minus 2, bring that down, equals, I'll even just wait here. Just bring it down. Let's do one thing at a time. Negative 5 minus 5 is negative 10. And we can combine these because they're both being multiplied by the same thing. So this is plus 15 minus x. Alright, now we still have a radical. So what we want to do is isolate the radical, and then we're going to square both sides. So isolate this whole term. So I need to move over my 25 and my 15, and my x. So on the left side, we're going to do x plus x, right? I'm going to add x, so we get 2x. Then we have negative 2 minus 25 minus 15, so that's negative 42. Yep. And then I've got my minus 10 times the square root of 15 minus x. Now, at this point, you could do a couple things. You could either isolate it completely and divide by the negative 10, but you'll end up with fractions. But because this is being multiplied, you could just square this whole side. So because it's being multiplied, you're not going to have to just double distribute because it's all just one term. So I'm just going to, from here, square both sides. And now this side, because it's two terms, you have to FOIL. So this is 2x minus 42 times 2x minus 42 equals negative 10 squared, right? Because it'd be negative 10 times negative 10 is positive 100. And then the square root of 15 minus x times the square root of 15 minus x would end up being just 15 minus x. Now be careful, this negative 10 is being multiplied, so it's still being multiplied. So now I'm going to double distribute or FOIL on this side. So 2x times 2x, yeah, these are long problems, is 4x squared. And then what we have, 2 times negative 42, and then another one, so negative 168 when I combine them in the long run. Negative 42 times negative 42. Okay, and then I'm going to distribute over here as well. So 10 times 15 is 1500. 100 times negative x is negative 100x. Okay, so now we're still solving for x, that's our goal, but what do? Because you see a quadratic here, right, x squared, you should be immediately thinking, okay, well, if I want to solve a quadratic, it needs to equal 0. So I need to move my 1500 over and my 100x over. So I'm going to have 4x squared minus 168x plus 100x, so 68. And then I have 1764 minus 1500, so that's positive 264. Now I can either solve by factoring the quadratic formula or completing the square. This actually is going to factor nicely. Each of these has a 4 is divisible by 4. So I'm going to factor out a 4. And I'm left with x squared minus 17x plus 66 equals 0. Now, what multiplies to 66 and adds to negative 17? So that's negative 11 and negative 6. And now, to solve, I can use the zero product property. So I'm going to set x minus 11 equal to 0 and x minus 6 equal to 0. I could do 4 equals 0, but right, that doesn't matter. If it were an x, it would matter. So x equals positive 11, x equals positive 6. And hopefully you remember this from last year, but we're not done, and you guys are going to love that. Miss Summer has a super cute saying, when you square, you care. So you need to check your answers. So because we squared both sides, we need to check, is 11 a solution and is 6 a solution? And you need to show your work. So now we're going to check both. So we need to check x equals 11, and then we need to check, give myself some space. And when you check, you substitute it into the original equation. So I've got the square root of 11 minus 2 equals 5 minus the square root of 15 minus 11. Right, so 11 minus 2 15 minus 11 simplifies, so the square root of 9 is 3. Left with 5 minus the square root of 4 is 2, so 5 minus 2, and we get 3 equals 3. So it appears that 11 is a solution. And then for 6, we got square root of 6 minus 2 equals 5 minus the square root of 15 minus 6. Right? So 6 minus 2 is 4. 15 minus 6 is 9. So we get 2 equals 5 minus the square root of 9 is 3. So we get 2 equals 2. Couple of things. So actually both of these are solutions. That is not always the case. So is this a lot of work? Yes. Do I need to show my algebra? Absolutely, you do. There's a lot of work that's required. I would say showing me that you squared both sides. I guess you could skip to this step if you wanted to, and then this step. But I really think you guys should show this. And then you could skip to this step, but I'm telling you guys, kids really don't remember to expand it and distribute. Setting it equal to 0, you need to get your, you'd have to show like everything here. Your answers, and the checks are required. And for the checks, you do need to go all the way down and confirm. So like this is a proof. You're proving that this side equals this side. You shouldn't be moving things around. It's you simplify one side, you simplify the other side. You don't touch anything. Okay, so isolate radical, square both sides. Simplify. And repeat if necessary. Alright, so this is one of the more challenging problems, but because it's pre-calc and not algebra 2, it's very likely that you could see this on an assessment.